Seriously, I don't know why is the setting wants somebody to let it because I never received anything to like enable people to join. Seriously, I don't. Um, I guess they have to follow the YouTube video later on, unfortunately. So people, I think I cannot wait any longer. I will just start with the lesson. And then the rest of it who cannot join, maybe you can join the YouTube video later on. Yeah? So don't worry, we're going to come back to that later on. I'm going to start with the next lesson, which is about soil acidity. Now, in essence, this lecture will be talking about how soil pH affects the usability of the soil. So it's not just for agriculture, it's for everything. Because when it comes to pollution and its effect to human and also agriculture, pH can be said to be the major source or the major factor that can determine whether that soil is good or is bad. pH alone, seriously. Yeah. Okay, now for introduction, I think I don't need to introduce to you what is pH and what are the all everything. By the way, this slide actually is the main points of the details that we're going to go into. So before I go into the details, so what pH is so important because it actually can determine a wide variety of chemicals and in essence it also affect other parameters. So soil pH can determine whether a nutrient can be absorbed by plants or not. The soil pH can actually tell that. The other factors is also can also tell you whether a pollutant is dangerous to human because a soil can be said to contain heavy metals, but at some pH, these heavy metals is not dangerous to human. So don't think that the soil who have toxic heavy metals, they always need to be treated. No, not necessarily, because if there are certain suitable pH, these heavy metal will not harm people. Yeah. And then last point, soil pH is a critical factor in predicting the likelihood that given pollutants will contaminate groundwater, surface water, and food chain. So there you go again. At certain pH, some heavy metals might comes up in your groundwater, and this is how they harm human if people consumes it. And also, if it is a wrong pH, this heavy metal might go into the food chain. So without further ado, it's like now this one I think I can skip already kan? Because this one I believe you have seen it before in secondary school. So I will skip lah. Now, probably here I'm going to stop a while and explain to you what is the pH range. So basically, neutral pH is 7. Everybody agrees on that one. Anything higher than 7 is considered alkaline. So the higher it is, the more extreme the alkalinity. So if it's nearer to 11, it says to be very strong basic or very strong alkaline. I haven't seen any soil that reach beyond 11, but I believe there is because limestone soil that majority of the limestone can be as high as 14. But it also can go to the other end. Now, any pH less than 7 is said to be acidic. It could be up to 3. And believe it or not, some of the soil samples can reach as low as 1 or maybe even minus. Oh, by the way, the strong acid that you use in the lab, like for example, your sulfuric acid or nitric acid, when you measure the pH, don't be surprised. The pH value can get to -1, negative something. Yeah, it can be that strong acid. But in nature, naturally, these are the normal pH you can see right here. Yeah. So it depends on what conditions that cause soil to be acidic or alkaline. If you have more limestone, automatically it becomes more alkaline. I think beyond that, not many soils can be alkaline. So usually alkaline soil are those from arid region. Arid means dry and hot, uh, like the deserts. Desert is said to be arid region. So usually they will going to accumulate a fair bit of earth alkaline metals. So that's why they're alkaline. However, on the other side, on the other end, if it's more acidic like here, it is mostly due to the presence of organic matter. See, humid region, mineral soil, and then if you are very extremely acidic, it has peat soil. Now, the presence of organic materials alone, if you say just organic material, they themselves is not very acidic. Now, the very reason why peat soil is acidic is due to microbial activity. After this, I'm going to explain more to you why peat soil, they are very acidic. But of course, there is one more factor that is not included here. That is, I think you should know also, the anthropogenic pollution. Yeah, anthropogenic pollution also causes the majority of acidification of soil, in which I'll also going to explain to you later. Yeah. So this is the outline of the content that we're going to learn for the next hopefully 30 minutes. The cause of soil acidity, effects to plant, effects to soil pH and its nutrient availability, and how to solve this problem. But of course, in between, we're going to explain how pH becomes acidic and how pH becomes alkaline. Okay, now we're going to begin with the cause of soil acidity. So earlier, I've told you peat soil is acidic due to microbial activity, but there are actually many. So the first one, carbonic acid. I'm sure you've learned this is from rainwater. Naturally, it contains rain. Natural rain contains carbonic acid. I'll explain later how. So microbial metabolism, microbial activity, as well as the accumulation of organic matter. These two actually comes hand in hand. They come in together. Whenever you can find organic matter, you will find biological metabolism, and together they contribute to acidic soil. However, there are other factors as well. Oxidation of nitrogen, oxidation of sulfur. Remember just now I said anthropogenic pollution. These are the two: oxidation of nitrogen and sulfur. Again, I'll explain to you more about that. And because of this one, they mix with rainwater and it becomes acid in precipitation and plant uptake. So basically, there are three factors I would say, two of which is natural. One is due to man-made. Oxidation of nitrogen, sulfur, and acid precipitation. These three, right here that I'm encircling, they're actually man-made. They're actually caused by anthropogenic pollution. The rest of it is naturally occurring. Yeah, I'm saying about carbonic acid, acid in biological metabolism, accumulation of organic matter, and plant uptake. These happen naturally. Yeah. So don't you worry if you don't get what I said just now, because now I'm going to explain to you one by one. So I'm going to start with carbonic acid. Now, natural rain, natural precipitation, if you say the first instance of rain after a long period of drought. So after several days of no rain, suddenly you have one rain. If you manage to collect the rainwater, it may have a little bit of carbonic acid. And it's normal to have rain pH around 5, 4.5, 5.5. That is natural actually. But sometimes you may find out that this rain pH, if it's raining too heavily, it comes back to 7. So it fluctuates a lot depending on how much of carbon dioxide that you have. Because carbonic acid, as you can see right here, H2CO3, this is the carbonic acid, is produced by the interaction between carbon dioxide and water. And they will become acid when they dissociate. So this two-directional arrow, as you can see right here, is the dissociation where they produce one hydronium H plus. So this is the acid, yeah, this one that causes the acidity of soil. And when you go to like places like Gua Tempuro, Gua Nia, you have stalactite and stalagmite. How does calcium carbonate are being sort of dissolved? This is how they dissolve. They dissolve due to the presence of carbonic acid. Okay, moving on to the next one, acid from biological metabolism. So I think I'm going to discuss together with the next one, accumulation of organic matter lah, yeah. But first thing first, microbial activity or biological metabolism can only arise if there are presence of organic matter. Or in this case, it comes from the breakdown of soil organic matter. Now, as you know that this organic matter can be from plants, can be um, from animals. Now, as long as microbes go and breaks them down, they will produce organic acid. Now, I won't go to click here. You can actually click it yourself and find out what are those organic acid. So when I say organic acid, they contains primarily carbon, a lot of carbons. And what are the functional groups that gives them acid? As you can see right here. Functional groups such as carboxylic acid. And I think that is it. Now, sometimes people say hydroxyl is acidic. Uh, Technically, yes. Hydroxyl can be an acid. But why do you always hear carboxylic acid? Because this one dissociate readily to give you the hydronium, like this one. Whereas hydroxyl, they don't give you this H plus so easily. They don't. They cannot break this and they cannot give this one. Hydroxyl will only become carboxylic acid after this reaction, and it's called oxidation. So I put this one, an arrow here means oxidation. After oxidation of hydroxyl group, then only it becomes carboxylic acid, and therefore it gives you the acidity. And this oxidation usually is due to microbe. Microbe does this job. Yeah? So I think that one clarifies everything. It comes from organic matter, and due to microbial oxidation, they break down and then they oxidize it. They give you this carboxylic acid. And one of the common organic acids that produce from microbial metabolism includes citric acid. This one, you can find out how it looks like. It has 3 carboxylic acid group, or maybe malic acid. So yeah, if you want to know the structure, click it yourself and then you can know it yourself. Yeah. Now, the other thing that also can give you a little bit of acidity is humic substance. You see, this one is essentially a soil organic matter. Have you heard humus before? Yeah. Humic acid is the scientific name for humus. Humus that you can see the dark organic matter in the soil. Yeah, this is how they look like. Now, the structure is very complicated, but with a click of this button, with this link, it brings you to Wikipedia and you can see how complicated they are. Again, they are majority of them carbons. They have a fair bit of hexagon ring, benzene ring, and with that benzene ring, it actually gives a stronger acid. Yeah, I'm not in favor of teaching you chemistry because I know chemistry can take a long time to understand. So I think I'll just move on to the organic matter, accumulation of organic matter. Now, following on the humic acid that I've explained to you earlier, why this humic acid is considered acidic. Now, that is because the organic matter have these 2 functional groups, either hydroxyl or carboxylic acid group. Now, these 2 cannot be acidic. It won't become acidic unless this happens. So once again, from left to right, this reaction is called dissociation. Where is dissociated? H plus. H plus dissociated from carboxyl group. H plus also can be as dissociated from hydroxyl. Now, earlier I said to you that it's quite impossible to have this reaction from OH to O minus N. Well, that is possible if this OH is attached to a benzene ring. Yeah, if it's attached to a benzene ring, this can happen. However, if it's attached to any hydrocarbon, long hydrocarbon, it's not going to happen. Yeah, long story short, that is organic chemistry. I am not teaching you organic chemistry, so I'm just telling you that you have organic matter, this will happen. Okay? And how does this further brings down the soil acidity? By forming this complex. So when you have this negative charge on the surface, it can actually binds with the positive cations such as calcium 2 plus or magnesium 2 plus. Now you must be wondering, how come bonding between these two cations will further brings down the acidity? Now for your information, these two cations are earth alkaline metal. So which means if these two are present in the soil become alkaline. However, if organic matter binds with these two cation, it will going to acidify the soil. That means they can no longer makes the soil alkaline. Okay, so this is part of the one of the reasons why peat soil they are so acidic, because they trap those alkaline metals, and then they also at the same time can release the acid, which is H plus over here. Okay, moving on. I think this one is quite easy. I believe you learned this before, so I'm not going to talk too much. What I can say is that this one, previously you must have blamed this oxidation of nitrogen from combustion of fossil fuel. Yeah, that is, I remember exactly, because I taught pre-U course before, diploma. They always blame on the oxidation, the combustion of fossil fuel. Because when we have a combustion engine and we burn fossil fuel, our air actually contains around 70% of nitrogen gas, and when they burn, it becomes nitrogen oxide, and that is when it becomes, and therefore it becomes this one, the nitric acid. Now, what I'm going to tell you more is that actually agriculture also can cause this one. The way they have this reaction is quite different. It's not through combustion, it's by putting in fertilizer. See this ammonium? Yeah, this one comes from the fertilizer. This ammonium, when you put it in fertilizer, it does not stay ammonium forever, because we have oxygen in the air, and these two react readily. So this one is quite naturally happen. The ammonium in the fertilizer will be oxidized by the atmosphere, our atmosphere that we're having right now, and they themselves become nitric acid. And guess what? This is actually the major problem in oil palm estate. If anybody here, kampung at Felda, you probably have some waterways near oil palm estate that have like blue-green color and so on. One of the contributors of the bad water quality in these waterways is this one, oxidation and acidification of water by simply putting fertilizer. Okay, next one is oxidation of sulfur. Okay, now this one is clear cut from the soil itself. While earlier the oxidation of nitrogen comes from fertilizer, this one probably a little bit different. Now, sometimes farmers also use a little bit of sulfur in the soil. Because sometimes the soil may not have the good pH, putting in sulfur acidify it. But the way they work is quite similar. What is needed here is anything that contains sulfur. Now, in this case, iron sulfide, or in other words, we call it pyrite. Now, if you haven't seen pyrite before, this one looks exactly like gold, shiny, yellowish, but it's not gold. It only contains iron and sulfide. So this is sulfide, and this is all it takes to actually acidify the soil. And once again, how does it happen? The oxygen in the atmosphere. It will oxidize the sulfur in pyrite, and then it becomes sulfuric acid. Now, you probably cannot see sulfuric acid because the sulfate already combined with iron. So this is actually from the sulfuric acid. What you get is these two H plus. And this is also one of the major reasons of soil acidification in a few parts in Malaysia. Now, the take-home message is that if you have any sulfur element hanging around exposed to oxygen, it will become acid. So it doesn't have to come from pyrite. It also can come from your belerang or sulfur powder, the yellowish color ones. They also can do the same job. As long as you have sulfur element and oxygen, you will have sulfuric acid. And once again, I think these are YouTube videos. So after this, go click it yourself and then watch the YouTube video on how sulfur can be oxidized to become acid. And this flow diagram shows you exactly how sulfur element from the center of this diagram can be oxidized upwards. So if it moves up, it slowly oxidized to become sulfuric acid. So this is the last destination. It becomes sulfuric acid, and this is the strongest acid they can become. But at the same time, if you don't have enough oxygen, let's say this sulfur is buried deep in the soil, or maybe the soil moisture completely submerged this sulfur, it may becomes reduced because without oxygen, it will be reduced and it becomes thiol. This is what we call it, HS. In other words, we call it thiol, so it becomes organosulfur, and this is the one that gives you the rotten egg smell. Yeah, this one, the rotten egg smell. Yeah, a lot of chemistry. You can refer to that later on. Yeah. And then what else? Yeah, the pollution. As I said to you just now, air pollution. If the air contains a little bit too much of nitrogen oxide or sulfur dioxide, it's the same thing. You get more nitric acid, you get more sulfuric acid, and therefore the pH of rainfall becomes acidic. Okay, now before I move on to the last cause of the acidity, actually in urban areas like in Klang Valley, most of the soil in Klang Valley actually having a soil pH of 3 to 4. It's quite acidic. Reason because of the cars and the factories that we have in the urban area. So that is the source of those nitrogen oxide and sulfur oxide. And therefore, when precipitation comes down, it brings all this acidity back to the soil, and therefore the soil, for example, in PJ alone, maybe even Shah Alam also, the soil pH, if you say 4.5, that's quite normal. That's quite average, actually. Okay, now moving on to the last cause of soil acidity, you probably won't think of this, but it's natural. It's due to plant uptake. Now, earlier I told you the presence of calcium causes soil to become alkaline. Without this cation, the soil becomes acidic. And this is precisely what the forests do. You see, forests actually have a lot of big trees, and these trees exist for such a long time. So in essence, these trees has been absorbing from the same spot, the same cations as its essential nutrient. And part of this nutrient, apart from ammonium, is also calcium. Now, calcium is the major source of mineral that gives you the alkalinity. Now imagine one tree already exists in one same spot for the past hundreds or maybe thousands of years. Guess what happened to the soil? Yeah, it becomes acidic. So this is not due to human pollution. It's not due to pollution. By having extensive uptake of these alkaline cations, the soil naturally becomes acidic. Which is why if you go into the forest and you take some of the forest soil, it is naturally acidic. Yeah, this always happen in the forest lah. So don't think that the forests have pollution. It is natural because trees taken away all those alkaline cations. Okay, so now we move on to the effect of pH. But before that, I think we already have half an hour of lesson. I'm just going to come back to you guys over here. You all need a 5-minute break. If you need a 5-minute break, type in the chat box, say yes. You need a 5 minute break. Yes. Okay, so now I'm going to stop the recording